So actually, I will focus on the regulation of the one of the PTM, the simulation in vascular remodeling. That is the works like we did in our lab in the last 7 to 8 years. Yeah, I think everyone is familiar with the relationship between the cardiovascular disease and the vascular remodeling. Actually, we've just focusing on the vascular remodeling, mainly initiate from the endothelial cells activation, and it will just result in the new intima formation and vascular remodeling in some arteries, and also it refers to the vascular network building like angiogenesis. Why we are interested in the PTM or the post-translational modification, as we know most cardiovascular disease are involved in the protein interactions mediated by the PTMs, and that will affect the protein's stability, structure, and activities. And here I just found that listed some classical or well-known PTM like phosphorylation, the ubiquitination, and also some newly discovered like simulation we are focusing on. So what is SUMO? So if you found go online to search SUMO, SUMO, you will find most pictures like this. Yes, this is the name of the traditional sport in Japan. And for PTM, the SUMO, the full name is more ubiquitin-like modification, and it shares some kind of dynamic switch like the sport. So that means the simulation and desimulation, I think, are both equally important for its functioning. And so by the E1, E2, and E3, the SUMO molecules conjugate to their substrates, and the desimulation are performed by the desimulase family SEMPs. And so far, originally people just focus on the nuclear proteins like the substrate, but also it extended to the some cytoplasmic proteins and also receptors. I reported later. And our story just started from the knockout of the major SEMP member, SMP1 in mice, and the mice died from E30.5 to day 0, and obviously you can find the ischemia phenotype, that is the overstimulation of the transcriptional factor GATA1 will block the erythropoiesis signaling. And also obviously there are some defect of the cardiovascular system. So based on this, we after I come back to China, so I will have the first story just investigated the role of simulation in GA, the graft arteriosclerosis. Of course, first the major reason is the GA is a major cause of the organ failure after transplantation, but also it is a typical vascular remodeling event. And we find the clues in the clinical specimen. So in the microarterioles in the rejected heart after transplantation, we can find the induction of the SEMP1 in the endothelium layer, and accompanied with the induction of the GATA2, as well as the endothelial activation. And once we go back to the bench work, we established the GA model in mice. We transplanted the donor male thoracic aorta into the recipient female abdominal aorta. So the minor Y antigen will result in the new intima formation and the vascular remodeling in the graft. But once we knock out the SMP1 in the endothelial cells, so it limited the GA progression as well as the vascular inflammation. So the major reason is the GATA2 simulation different from the GATA1 in red blood cells. Here in endothelial cells, the GATA2. So in this story, basically we find the pro-inflammatory cytokine will induce the expression of SMP1, the desimulase, and this results in the desimulation of both the GATA2 and IKB alpha. So the resultant transcriptional complex drives the endothelial activation and the GA progression. And recently we also focus on investigated the role of simulation in the other important cardiovascular disease, that is hypoxia-related pulmonary hypertension, that is group 3. So yeah, this is also characterized with vascular remodeling in the pulmonary arteries. And actually the dysfunction of the endothelial barrier is also one of the major causes. And concerning the oxygen oxygen metabolism and the hypoxia. So we just interested in the mitochondria because the small volume of the mitochondria in the endocellular cells, they looks like does not generate the ATP for the endocellular cells, because endocellular cells obtain the most of ATP from the glycolytic metabolism of glucose. So people think the mitochondria in endocellular cells may just works like a signaling organelle rather than the energy generator. So our study just also started from the clinical specimen in the clinical specimen of the group 3 pulmonary hypertension. So in the moderate group, we can find the most of the mitochondria in endocellular. I mean the pulmonary endothelium are just a normal, although a kind of fishing. But the severe group just show the overfishing and fragmentation, and accompanied by the hypoxia, sustained hypoxia accumulation. And also in the moderate group, we can find some of the SMP1, that it can translate from the nucleus to the mitochondria. But for the severe groups, the SMP1 looks like there is some kind of degradation. And we also confirm this in vitro, and because based on the fishing phenotype, we finally fix the target of the stimulation here is the fishing protein FIS1. And then we ask what is the stimulation or destimulation of the FIS1 during the primary hypertension. In the hypoxia-induced pH model in the mice, we find that there is an interesting switch. At the early stage, there is destimulation of FIS1, and it looks like can retard the pH progression. But once it switch to the overstimulation, so the disease is developed severely. So that means indicates that could be at the early stage, the destimulation of FIS1 could be played a protective role or protective mechanism. So what is the molecular mechanism after that? So again, we just confirm the SMP1 translocation from the nucleus to the mitochondria, and also in the short-term treated hypoxia treated endocellular cells, and in which that is actually the SMP1 translocate into the mitochondria and further associate with FIS1 and induce the destimulation of FIS1 there. And this destimulation actually just does not affect the stability of FIS1, but affect its classical function, the fishing. So overstimulation of FIS1 induces the overfishing and fragmentation of the mitochondria, and subsequently disrupt the MAM, that is a subcellular membrane structure between the ER and the mitochondria, and the blue ones are indicated as the MAM, and consequently affect the calcium transfer from the cytoplasm into the mitochondria. And this finally disrupt the cellular metabolism. Here we just show the destimulation form can preserve a better oxidative phosphorylation, but can limit we just call this a bad signature for the of the glycolysis. That is a bad signature or the for the phenotype of the endocellular cells during the pH. And once we come back to the in vivo, so once we overexpress the simulated FIS1 form, it's consistent can enhance or exaggerate the pH progression, the vascular remodeling, and also disrupt the MAM formation and the endocellular dysfunction, induce endocellular further dysfunction. And once we try to introduce a FIS1 mutant, that is destimulated mutant, it can preserve some of the MAM structure and maintain a better cellular metabolism, and can partially inhibit the pH progression here. So, in this story, so we just find that in the early story, in the early stage, of after the short exposure of the hypoxia, it will induce a SMP1 translocation from nucleus to the mitochondria to works to induce the destimulation of FIS1 and maintain the calcium communication and the mitochondrial hemostasis. But upon the sustained hypoxia, it will induce the MIR-138 mediated SMP1 degradation, and this is just resulted the disruption of the cellular metabolism, and based on the overstimulation of the FIS1 and the resultant and the cellular dysfunction and the pH progression. And also, we recently we also focused on the simulation in the astral. So as we know, by cooperating with Dr. Michael Simon at Yale, so we just mainly focus on the endothelium phenotype switch at the early stage. We call this endo-MT. So because our previous studies just show the FGF and the FGFR1 signaling just played as a protective role against the bad signaling, TGF-beta signaling here. But however, once we try to knock out the FGFR1 or even all the FGF receptor families in the endocellular cells, that we cannot check just find some mild phenotype here. So luckily, we find that the two classic simulation site in the tyrosine kinase domain in the FGFR1, and this kind of simulation just can respond to the pro-inflammatory stimulation in endocellular cells. And more importantly, in the clinical specimen, we find that in the astral plaques in the endothelium, the colocalization of the FGFR1 and SUMO1 just decrease a lot, but there is a translocation of the SMP1 from the nucleus to the cytoplasm. So based on these clues, we just constructed the mutant mice as FGFR1 destimulated mutant mice based on the ApoE knockout using the wild type as control. And obviously, once we feed the 2 months of the high-fiber diet, it's increase the mutation just increase astral progression a lot, and even more obviously after 3 months. And at the early stage, we just find there is an obvious endo-MT enhancement in the mutant mice in the endothelium in the plaques. So what is the mechanism? So in vitro, once we treated the endocellular cells with the pro-inflammatory cytokines, we can see the morphology change. But at the molecular level, we just find the major change is degradation of the FGFR1, but only at the protein level, but not at the mRNA level. That means PTM may play something here. And definitely, indeed, we just find the simulation can preserve some of the stability of the FGFR1 upon the treatment of the pro-inflammatory cytokine. And once we give more SUMO1, so it can protect its degradation. And the destimulation form, even in the heterozygotes, can induce or promote the degradation. So this degradation actually finally we find it is just based on the lysosome degradation pathway. So the destimulation form just induce the we call it disrupt the recycling of the FGFR1 intracellularly. So it cannot go into the early endosome, but almost all go to the late endosome and the lysosome and treat the FGFR1 like some kind of protein garbage. And the mechanism here is that I think the key one is the simulation have a crosstalk with the ubiquitination for the sorting. So basically, the paper we just submitted. So we just find the simulation on the FGFR1 have a crosstalk with the ubiquitination and maintain its sorting in the intracellularly, and also affecting the NF-kappa B signaling, and finally mediated or just crosstalk with the TGF-beta signaling, and regulates the astral progression. So interesting. So the one of the paper we just published collaborated with Dr. Michael Simons and Zoltan at UPenn. We just find that the TGF-beta receptor also its acetylation is also important for this kind of phenotype during the endo-MT. And indeed, we also find some new clues between the simulation and the acetylation in these data. I think this maybe just make some new work and to illustrate this kind of mechanism in the future. And also, we did some work in the angiogenesis, the simulation in it. So just to focus on the endocellular tip cell to stalk cell, the signaling. One is positive, the VEGF signaling, and maybe also the FGF signaling, and the negative signaling, the notch signaling in endocellular cells. So we use the retinal angiogenesis model in mice, and actually, the SMP1 mainly expressed in the angiogenic front here. And once we knock out the SEMP1 in the endocellular cells, it showed retarded angiogenesis evidenced by the vascular area and also the tip cell and the philopodia numbers. So, but once we give the because we see the inhibitory phenotype, but once we give the mice like the inhibitor of the notch, it can mostly rescue the phenotype. And actually, the simulation just directly target on the intracellular domain, the NICD of the notch one, and will inhibit the VEGF-R2 and VEGF-R3 signaling. So, in this first story in the angiogenesis, we just found the simulation on the NICD domain of the notch one that played multiple roles by both all the cleavage of the notch one at the membrane, and also maintains stability in intracellularly, and also to facilitate NICD transcription. Involved transcriptional transcriptional complex formation in the nucleus and against the VEGF receptor signaling. And actually, the work we just finished up is we just extended the simulation in the notch signaling, as also it can target on the HA1, as there is the further feedback to the notch signaling and to the VEGF signaling, which is also in the minor revision recently. And yeah, finally, we also investigated the simulation in some positive signaling I just mentioned before, just focusing also in the FGFR1 in endocellular cells. And actually, it's just comprehensive modulate the tyrosine kinase activation by both affect its dimer formation and its association with phosphorylation kinase like the PTPRGs. And therefore, based on that, it just affects the recruitment computation. I mean, the FAS2 alpha between FGFR1 and VEGF-R2. And this is also confirmed upon the physiological stimulation like hypoxia. So, in summary, for this part, we just find that in the classical hypoxia-mediated angiogenesis, so the hypoxia will induce the simulation of the FGFR1, then it will limit its additional recruitment of the adapter protein, FAS2 alpha, and just guarantee the complex formation between VEGF-R2 and FAS2 alpha and the subsequent signaling and for angiogenesis. But under normoxia, especially in some pathological angiogenesis, so the FGF2 will induce a desimulation of FGFR1 and augment its signaling, which could be the major driving force in that case. So okay, so the finally just a brief in summary for our all these studies. So of course we find some dynamic regulation, the simulation desimulation switch in vasculature, and I think we think the future direction could be to focus more on the crosstalk with other PTMs, and I mentioned there are varieties of substrates across the vascular cells, especially in endocellular cells so far. This is mainly because the just different performance of the EMPs, either for the distribution and expression upon the different stimuli. And for the therapeutic perspective, so we think that the SMP inhibitors are agonists, and also we can introduce some mutants, and also some kind of natural products like from ginseng can affect some kind of specific simulation. Okay. Oh, sorry for the time. Anyways, finally, just thanks for all the members involved and the collaborators and the fundings. Thank you very much.